Good evening everyone. I am Dr. Shalini Hanok, Associate Professor, Department of Electronics and Communication Engineering, ATME College of Engineering, Mysore. Today I will be discussing one of the experiment in digital communication lab, that is BECL 504. Experiment number 7, perform the Qpsk modulation and demodulation, display the signal and its constellations. Before going to the hands-on using the tool, we'll be discussing what exactly is QPSK. QPSK is basically quadrature phase shift keying. So quadrature phase shift keying is a type of M-array PSK. The odd numbered data from the input bit stream is known as in-phase data, and even numbered data is known as quadrature phase data. Two consecutive successive bits are combined, known as D bits, to form symbol. QPSK is represented using 4 symbols. Each symbol is made up of one in-phase data bit and one quadrature phase data bit. The symbols are represented by phase shift such that the phase difference between two adjacent symbols is 90 degree. Rate of change of output baud rate is equal to 1/2 of the input bit rate. So this is a block diagram of QPSK wherein we have digital data coming in. So odd and even are separated using two channels, I and Q channels. And finally, the Q channel data is 90 degree out of phase, and that is finally summed, and we have a demodulator block diagram. The signal is given into the modulator signal is given to it. The product detector is going to separate the two Q channel and I channel, and finally we'll be getting demodulated waveform. So in QPSK, the binary data stream is divided into pairs of consecutive bits. Each pair is mapped to one of the 4 states. The relationship between these bits and phase states can be summarized as below. So we have in PSK and ASK FSK, we have one single bit a single bit used for modulation. Here we are using 2 bit for modulation, and we have 4 different symbols, that is 0 0 0 1 1 0 and 1 1. So each having a phase shift of 45 degree, 135 degree, 225 degree and 315 degree. This is the constellation points waveform, and along with the constellation diagram we have for 40 degrees the point lies on the first quadrant 40 degrees, and this is a waveform for 40 degree phase shift. And for 135 degree, so the point lies on second quadrant, and this is a waveform for the 135 degree phase shift. And for 225, that is 10, the point lies on third quadrant, and this is the waveform. And for 11, the phase shift is 315 degrees, it lies on the fourth quadrant, and this is the waveform, and this is the constellation diagram showing each point in each different quadrants. So this is the constellation diagram which we will be able to simulate in MATLAB using Simulink. So where in each point will be having will be present in the different quadrants. Now we can observe from this diagram, since all are having the same amplitude, so it is for the all the points lie on the same circle. So each symbols have 180 degree difference between them, that is 11 to 101, the phase angle is 90 degree. From 01 to 00 it is 90 degree, 00 to 10 it is 90 degree, 10 to 11 it is 90 degree. So this is the constellation diagram we will be able to get after the AWGN channel introduces noise. So this is due to noises. And this is a diagram for QPSK. We have random integer generator, QPSK, AWN channel and QPSK demodulator. We'll be seeing the constellation diagram and also the waveform on the scope. Now the advantage of QPSK is it is efficient use of bandwidth. It doubles the data rate compared to BPSK. It robust against noise and interference, widely used in satellite and wireless communication. This is an application: satellite communication system, Wi-Fi and cellular system, cable modems, digital video broadcasting and so on. Now we are going to simulate the QPSK waveform. So we will be simulating it on MATLAB. So we have to go to Simulink. So in Simulink, um, select the blank screen, untitled one, and we have this different blocks of uh, the blocks which we need for QPS building the QPSK block diagram. So as we have seen that we need a random generator. So you have to go here. When you click on here, we'll be having different random generators here. Take the random integer generator. It is just a drag and drop tool. Then we have we want QPSK modulator and demodulator. Once we search here, we'll be getting, yeah, we have QPSK modulator as well as demodulator. We are going to drag and drop the modulator, then we are going to, sorry, drag and drop the demodulator, then we will be needing the AWGN block to introduce noise, so drag and drop that also. Then we'll be needing the constellation block to view the constellation diagram. So we have here constellation diagram, drag and drop. Then we'll be needing the scope, oscilloscope, to view the waveform. Okay, now we are going to connect it together. So random generator, after random generator we'll be using QPSK modulator, demodulator, AWM channel, and constellation diagram and a scope. So we will take two input oscilloscope. Now join them, random generator to QPSK, QPSK to AWGN channel, AWGN to QPSK demodulator, QPSK demodulator to the scope. From scope, we'll be giving it to the random generator. Constellation diagram, first we will view the constellation diagram here for modulator. So you click on save. So you save it as QPSK. It will be saved in the extension of SLX. Save it. We have to set some parameter before. Since it is a 4 channel, we are going to set it here. It is as 4. QPSK, there is no change in this. Go to AWM, even there is no change. The signal to noise ratio is 10. It can be 10, 25, anything. So QPSK demodulator. Okay, now we will run. Yeah. Once this runs, we have this constellation diagram which will be having 4 different points on 4 different quadrants. So now after introducing the noise, you can see the waveform, run it. Yeah, you can observe some noise. You can view some noise here which has been introduced. Now we will see the oscilloscope output. This is the output for randomly generated data. This is the waveform of Qpsk which we will be getting. Okay. Thank you.